in plain sight. It's just at the outside. If you shift them a bit back and forth, this also helps to distribute it evenly. And then it's put on a hot plate at a temperature of 150 degrees about. The solder starts to melt, and I used some screws as a load so that it doesn't swim away. And then it looks like this when the solder has melted. Transistors and this termination are soldered inside. And yeah, that's the result after full assembly of this amplifier. So I think now it's time to come to the real thing. So it's heavy, please be warned. It's heavier than you expect because of the big copper plate below. Yeah, this was the next stage of this prototype, still with homemade boards, but already mostly the geometry and the size of, let's say, the final product is that I use now for my DAs. So here you see a bit from the test setup. I want to emphasize once again that it's a good idea to use a circulator at the input, because when setting up these things, sometimes you even may change the power by changing the supply voltage of your driver or something like this, depending upon how your setup works. If you have a signal generator, or if you have a converter, or wherever this power comes from. And even if you don't do this, maybe the match of the output is not so good. If you reduce the output power of a module which is operating in class AB, it will no more have an impedance of 50 ohm, even if it is matched at its saturation power. And so for correctly tuning the input, it's very helpful if you have an isolator in between. So, yeah, that was the result. Once again, the blue line is the output power. The scale is different now. We have 300 watt here. So you see these 300 watt are reached and about 5 to 6 watt input power, again with some saturation already. And you have again efficiencies of more than 50%. This is 50%, and the green line is the efficiency starting from some 250 watt out to date. So I measured also at different voltages. At that time, I did not have more than 30.6 volts out of the laboratory power supply, the variable voltage power supply. So at this voltage, I came up to 340 watt. But this doesn't mean, I promise you now, that out of this amplifier you will always achieve 340 watt, because there will be some variation. And I would only say 250 watt at 28 volt should be guaranteed, should be possible to achieve with each well-made sample, and if you're lucky, it's a bit more. Yeah, I found out that adjustment was a bit more difficult with this than with a single module. It's also something I want to say to people who are maybe interested to reproduce it. Maybe it's even better in the first step only to sample one section, and or at least to connect one section to input and output, and to exercise a bit, to practice a bit with a single amplifier. And after you got some experience, then it's not so difficult. Now I think it's a thing of 20 minutes or so to tune an amplifier when you know how to do it. Yeah, but now we are at let's say 250 watt, and what I promised you is a kilowatt. So maybe this is not the end of the story. It's not. But to build more of these amplifiers, I also wanted to make printed circuit boards professionally. So it's not too difficult to make fabricate some boards in China for acceptable price, also on this material. Then you get good through plating. You can change some things a little bit, because now you have perfect ground possibilities. Yeah, there are also now it's even the second step of these boards. I have here also the boards for you to have a look on. They look so with these professional with these professional PCBs, sometimes at least. I built several prototypes, and here you can see a bit the variation of the output tuning. So we have 4 prototypes, and what you should watch is the position of these capacitors, here and here. Here it is in a lower position, here it is a bit higher, maybe also different from one side to the other. So you see, this is about the variation you have to find out during the tuning process, where is the optimum point, optimum tuning point. They also did not perform precisely the same, but the variation is reasonably small so that they can be combined into a bigger amplifier. I started to publish about this amplifier also during this time, started in 2014 and then 2015, so there were other people who were interested and made their own designs. Among them there was a big group in Russia, for example. They made their own board for the single amplifier and bought 150 of them in China and distributed them over Russia in 2014. There was also a Philip F5 Juliet Whiskey Foxtrot, who is an EME operator, who wanted to have his amplifier, his kilowatt amplifier, finally behind the feed of his dish. He has a 3 to 4 meter dish, something like this, and the feed out, and he wanted to have really the amplifier directly behind the feed. So he has built a version with 4 transistors and his own combiners, and put them on a heatsink so that he could use water cooling because of the weight restrictions he has with his EME feed. So he has made such a water cooler, as you can see here. And meanwhile, I met him in April in France again. Meanwhile, he has built a second module and put 2 together, sandwiched between this water cooler sandwiched between the 2 modules. And now he has his kilowatt at the feed of his dish with 8 of these transistors. So this is just another approach, which how you can combine the modules. It was not my approach. I said I want to stay at these modules with 2 transistors because they are easier to tune and then combine them externally. So this is the kilowatt amplifier, which is operating since last year. It still uses the old modules with a bit larger length. So this is professional PCBs, but this is still the older design with a larger length, larger size of the box. 4 of them, and then the combining at the output is done in a very simple way, because I had some isolators for 23 centimeters, originally for DOB 1400, which are retuned to 1296. And so I have put 4 isolators behind the 4 modules, and after that I don't need an isolated coupler, but can just use a simple antenna combiner-like coupler, which is easy to fabricate. We have a second photo of this, where you can have a look inside. This is not how it's operated normally, but, so that you can see a bit more of it. So you see here the 4 amplifiers. Again, these isolators, the output coupler, the output 716. And there is a driver module here. This Mitsubishi module, which gives about 30 watt, which is enough to drive these 4 modules via 4x1, the 1x4 splitter, Wilkinson coupler at the input. Again, I put an isolator inside, which is always a good idea if you have enough. It works at 30 watt normally, 29 point something. The 2 instruments are 50 ampere instruments each, so in fact it consumes about 85 amperes, something like this, which have to be provided via these 2 lines from a power supply. There's also a switchable input attenuator, so I drive the whole PA at the milliwatt level, or tens of milliwatt level, which is I find easier than to have an input in the watts range. So I always try to include the module. There's also a DC-DC converter, which produces a 12 volt for the module, and also I use it also for the bias voltage and for the blowers. Now the final question remains, where does the power come from? If you want 28 or 30 volt at around 100 ampere, you find quite some power supplies. Many of them are coming from telecommunications market, from base stations in this voltage range. Often they have smaller voltages, like 27 or something like this, so you have to find out how to increase it. I had several of these Ericsson-labeled Amazon power supplies, quite old ones, which were not so bad, but showed problems when I used the PA with SSB or CW, because the load regulation is very slow. So they cause quite a varying output voltage then, several volts, which is not good for linearity. And even if you want to use this controller board, which I had also, so that you control them via these plastic optical fibers and set the voltage to a different value, then you can increase the voltage. But there is then some kind of monitoring on the power supply, and this pulse-like loading is detected as a malfunction. And what the control board is, it switches down the whole power supply after some time. Then it restarts it after half a minute or so, but it's not very good for operation. So yeah, in one contest I used this power supply without the controller board at lower voltage, and was not very happy about having such a large variation of the voltage, but I wanted to try the PA. And then I was looking for something else, and if you look on another market where you can easily buy power supplies surplus, this is a market from server power supplies, from server farms, computer server farms. The problem is you find a lot working at 50 volt around, and you find a lot working at 12 volt, but you don't find anything, at least I didn't find anyone working at 24, 26, 28, 30, whatever volt. There is no big offer. But there is very interesting power supplies working at 12 volt. If you, I think it's a bit small here, if you look here, you can read, I guess, it's written 12 volt, 100 ampere. That's a power supply about this size, 1200 watt. And would be nice, would be exactly the right current for my PA, but yeah, what should I do with the 12 volt? So if you find there are people who are charging batteries for quadrocopters or things like this with these power supplies, and they have experimented a bit. Yeah, mostly they don't really know what they do, but sometimes you find in some forums one who knows a bit what he does, and at least they have connected them in series to 424 volts. But yeah, now trying to increase the voltage may not be the best idea, because then all the components are a bit outside of their specifications. So I prefer to say it's always good if you have a possibility to feed your larger power devices with three-phase. It's not necessary, but you can do it, so you can balance the power better. Why not use 3 of these power supplies? Again, why not use 3 of these power supplies and modify them for 10 volt. So there is some variation via built-in potentiometer, but it goes only down to 11.7 volt or something like this. But there is one resistor which you have to change, one resistor value, and then you can reduce the voltage even more. And so I modified them for 10 volt. I removed the ground connection at the output, which is there for safety reasons. For 2 of these 3 power supplies, connecting them in series. Then you have to add up simple startup resistors so that they start up if you apply for 230 volt power. And what came out of it? What came out of it was such a unit consisting of 3 of these power supplies mounted into an aluminum frame. Connected in series at the output. I added some filtering, some electrolytic capacitors, and some toroids, iron powder toroids, which have high enough saturation at this 100 ampere current. And 2 output sockets here. I use those nitric speak-on sockets for my 28 volt supply, which should be able to 50 ampere, which are quite low cost available. And now this power supply works quite well. The PA achieves its kilowatt output, and the regulation is excellent because the server also has some varying load, quickly varying load. I did not really check if the filtering is enough or if I have to do a bit more, but hopefully it will be, and I have to do this sometime. Okay, now we have 1 kilowatt. The question is, what comes next? This is not yet realized. This is just starting. Maybe 2 kilowatt, why not? Combine 8 of these modules. If you combine such a large number of modules, I don't have so many isolators that I can say that I put 8 isolators behind the 8 modules. But I was thinking about maybe building a Gissel combiner and starting with this. If you build this kind of Gissel combiner with only with 50 ohm lines, then you can use semi-rigid, and the 141 semi-rigid is good enough for 300 watt on 23. If you build it only on 50 ohm lines, in the combination point you have a very low impedance. It's 50 ohms through the number of modules. In my case it would be 8. And this means if I have these 6.25 ohms, which is here the center port of this combiner, then you have an RF current of 20 ampere there. So you have to be quite careful to distribute this current evenly among the surface of this final line. And then you let the final quarter wave transformer to 50 ohm, which is a 16, 17 ohm, something like this, characteristic impedance line, so a very thick inner conductor, another thick tube built into this. And okay, I realized this, I did not really test it until now. There is also the rest of the Gissel combiner missing, which has to go up there, and everything is becoming very three-dimensional, as you see, but yeah, it's not so easy. It's a bit hard with the 2 kilowatt. And I didn't start with the trick. So, my time is nearly over. To conclude the presentation, what I have shown you is that with this kind of transistor, which is quite easily available and quite cheap, you can build 150 watt power amplifier for 23 centimeter, which seems to work reliably and seems to be well reproducible. And if you adapt the material, you will end by something like maximum 50 euro or so for this amplifier. So the original target to make cheap modules, I think one can say, has been reached. I made then a PA with 2 of these transistors, which I would specify at 250 watt, which costs about twice this amount, around 100 euro, and which should, I think, perhaps help a bit to increase activity on 23 centimeter if people want to build these PAs, because the experience is that if you want to make things like airplane reflection QSOs or so, this would be the right level of power to have good success. But if you want to have more power, then you can combine multiple modules, which has been demonstrated in the moment up to 1 kilowatt, possibly in future even to higher power. Okay, that was it. Thank you for your attention, and we still have 5 minutes for some questions.
Nice work. Are you selling those 150 watt modules already as something?
No, I'm not interested really in making business out of that, so don't sell anything, but I sell, what I really sell, went through I think, are the PCBs for the twin amplifier, not for the single one. So if you really want to build only a single one, maybe you can cut out one of this board set, yeah. But yeah, I would recommend build 2 of them, and then you have it. Maybe the easier way. So if someone wants to have such boards, just ask me after the presentation. I have a few with me. I think it's, in the moment, about 100 sets are out in the various countries of Europe. But I did not have much feedback. Always costs time until the people have started to build the PA. Yeah, I bought via UT Source. This, I think it's HK UT Source or something like this, the name. While, yeah, I want to add something still. They are a chip broker, so they don't have their storage from these pile-up from these transistors, but they buy them themselves. And so I cannot guarantee that if I had good experience in the past 2 years, that this will continue. So this is at your own risk. Let me tell this, but my experience is okay. And They are not refurbished. No, they are new. They are new. Some surplus. They have what I receive have very different date codes from several years. So it's just something that for whatever reason went out and has never used. Yeah.
Thank you.
There are more questions. Okay, so thank you, and I think it's good if we close now because I think there is another presentation after that.